All right, what if I told you that you, yes you, already have a kind of superpower? I'm talking about the ability to move ridiculously heavy objects, not with, sheer muscle, but with a super simple, absolutely brilliant principle of physics. Today, we're going to unlock the science of leverage.
So let's kick things off with a little challenge. Picture this, a massive slab of stone. It weighs 1,000 newtons. That's over 220 pounds, or 100 kilos. I mean, it is not budging. But what if I told you you could lift it with just one hand? Seriously, how is that even possible?
Well, the answer is an ancient and, believe it or not, an incredibly simple tool, the lever. Yeah, that's it. Just by using a long bar and a pivot point, you can literally multiply your own strength. All of a sudden, that 1,000 Newton stone, it's totally manageable. Look, this isn't magic, it's physics, and it's a superpower that's available to absolutely everyone. Okay, to really get our heads around how this works, we're going to take a little trip back to the playground. Because believe it or not, the secret to the lever, it's something we've all experienced. It's the seesaw.
I mean, think about it. You've seen this happen, you've probably done it yourself. A small kid sits way out on the end of a seesaw, and they can actually lift a much heavier adult who's sitting closer to the middle, right? Closer to that pivot point. It's this beautiful trade-off. What you lack in force, or in this case weight, you can totally make up for with distance from the center.
This idea is so incredibly powerful that over 2,000 years ago, the great inventor Archimedes famously said this. He totally understood that with the right lever, the limits of human strength, they disappear. It's just an amazing testament to how a simple scientific principle can give us some pretty monumental power. All right, so this seesaw effect has a proper scientific name, but don't worry, it is not scary at all. It's called a moment, and right now we're going to decode exactly what that means.
So a moment is simply the turning effect of a force. That's it. When you push a door open, you're creating a moment. When you use a wrench to tighten a bolt, you're creating a moment. It's just a measure of that rotational force around a pivot, just like the center of that seesaw we were talking about.
And you know what the best part is? The math is incredibly simple. To figure out the moment, you just need two things. First, how much force you're applying. Second, the perpendicular distance from the pivot, which honestly is just a fancy way of saying the distance measured at a perfect right angle. You multiply those two together, and bam, that's it. You've got the moment. A simple, powerful recipe.
Okay, so we have the definition, and we've got the formula. Now, let's put it to the test with a classic balancing puzzle taken straight from our source material. It's time for the Great Balancing Act. All right, take a good look at this. We've got a lever on a pivot. Now on the right side, 30 centimeters out, there's a 100 Newton weight pulling it down. And on the left side, 20 centimeters out, we've got this unknown weight. We'll call it W. So the puzzle is, what does W have to be for this whole thing to balance out perfectly?
And this is the golden rule that lets us solve it. It's called the principle of moments. And all it says is that for anything to be in equilibrium, to be perfectly balanced, the turning forces in one direction have to exactly cancel out the turning forces in the other. In other words, the clockwise moments have to equal the anti-clockwise moments. Simple as that.
Okay, let's break it down. First, the clockwise moment. That's the force trying to turn the lever down on the right side. That's 100 newtons times 30 centimeters, which gives us 3,000 Newton centimeters. Got it? Okay. Now, the anti-clockwise moment is our mystery weight, W, times its distance, which is 20 centimeters. And for this thing to balance, those two moments have got to be equal. So, if 3,000 equals W times 20, all we have to do is divide 3,000 by 20. And what do we get? We get 150 newtons. And that makes perfect sense, right? You need a heavier weight on the left because it's closer to the pivot. That's that seesaw secret in action, right there. All right, so up until now, we've kind of been assuming that all our forces are applied at these perfect right angles. But let's be real, life is rarely that neat, right? So what happens when you add a twist? Well, that's where a related concept called torque comes into play. Take this wrench, for example. If you're trying to turn a really stubborn bolt, you might pull on it from all sorts of different angles. Now that simple moment calculation we did, that works best when you push at a perfect right angle. Torque, on the other hand, is the more powerful idea that can handle any angle, which, is how things actually work in the real world. Okay, here's probably the simplest way to think about it. Torque is like the universal, all-purpose tool for figuring out turning force. A moment is really just a special, simpler version of torque. It's the torque you get when your force is at that perfect 90-degree angle. Torque's formula just has one extra little piece to handle all the other possible angles. Now, please don't let that sine phi part of the formula intimidate you. All it's doing is figuring out which part of your push or pull is actually effective in making the thing rotate, right? Because if you push at a really shallow angle on a wrench, a lot of your effort is just wasted trying to stretch the wrench, not actually turn it. That sine phi just isolates the useful turning part of your force.
Okay, here's the really cool part. Once you understand moments and torque, you start to see this one, single, powerful principle absolutely everywhere.
It's in the crowbar you use to pry something open. It's the seesaw at the park, the wrench in your toolbox, even the simple act of opening a can of paint with a screwdriver. I mean, even your own body uses it. Your bicep pulls on your forearm, which acts as a lever, pivoting at your elbow to lift something. It's truly one of the most fundamental principles in all of mechanics.
And really, that's the key takeaway from all of this. This isn't just some dry physics lesson. Understanding leverage and moments, it gives you a whole new way to see the physical world. It's a mental tool that helps you understand how to apply your own strength in the most effective way you possibly can.
So, we've been talking about physical leverage this whole time, right? But the concept itself is so powerful that it's become a huge metaphor for life. So I'm going to leave you with this question. Where in your life, maybe in your work or your learning or even your relationships, where can you find that perfect pivot point where one small, well-placed effort could create a huge and meaningful impact?